Today we are going to talk about the 4 different types of chemical bonds that occur in nature. These 4 bonds are covalent bonds, ionic bonds, hydrophobic interactions, and van der Waals forces. Covalent bonds occur due to a sharing of electrons. Electrons can be shared equally or unequally. If they're shared equally, it results in a nonpolar covalent bond. As you can see in this diagram, the electrons are sort of in the middle. What this would mean is that the electrons are going to be distributed evenly on both sides, on both atoms of the bond. So it'll spend as much time on the left atom as it will on the right. If they're shared unequally, it results in a polar covalent bond. So one atom will receive the electrons more than the other atom. It's kind of like a game of tug of war where one side is winning more than the other side. So the electrons will spend more time around the right atom here, and this will result in it having a partial negative charge. Whereas the atom that the electrons don't spend a lot of time around will receive a partial positive charge. So here we have 2 carbon atoms, both of them with 4 electrons. If they were to undergo a covalent bond, the result would look something similar to this. So you have the 2 orbitals, and they would share electrons in the middle. They'd only share 1 pair of electrons in the middle, and they keep their other electrons alone. So these 2 electrons here are the ones that would be paired. In ionic bonds, you can give or take electrons. Atoms like to have a full orbital shell. For most atoms, this involves having 8 electrons in this valence shell, which is this outer shell here. The only exception to this are hydrogen and helium atoms, which want 2 electrons in its valence shell. Now, atoms tend to be very all or nothing. So this sodium atom here, because it only has a single electron, rather than try to make 7 bonds in order to get 7 electrons, it'd rather just give that 1 electron away in order to have a stable configuration with a full valence shell. So this chlorine is missing 1 electron, and so it's going to try to get that 1 electron. So this will result in an ionic bond with the sodium giving away its electron and the chlorine atom taking that electron. Note that for these diagrams, only the valence shell is shown. So the sodium, the valence shell will have nothing in it, and the chlorine will have the full 8 electrons for the valence shell. Hydrophobic means water hating, and this results from polarity, which you've seen here. So hydrophobic interactions are a sort of bond where 2 hydrophobic molecules try to stick together and try to push out anything that's polar. So hydrophobic molecules are by their nature nonpolar, and nonpolar molecules like to be around nonpolar molecules, and they try to avoid being around polar molecules such as water, which is where it gets the name water hating. So in this sort of demonstration, we have oil being poured into a beaker of water. Now, what's going to happen, if you've ever seen oil and water before, is they're going to separate. So that you have a layer of oil on the top and your water remains on the bottom. This is a type of hydrophobic interaction. So the hydrophobic molecules of the oil are going to cause them to stick together and push away the water molecules underneath. The last bond that you should know are van der Waals forces. These forces result from random electron movements because remember that the electrons don't stay in one place, but they're constantly moving around the nucleus of the atom. So similar to if you had a bunch of kindergartners and you told them all to run around, there is a slight chance that all of the electrons or all of the kindergartners will clump together in one general area. The area that they clump together in is going to receive a partial negative charge, and the area that they're kind of away from will receive a partial positive charge. So this is partially positive and this is partially negative. If this happens to two atoms that are close enough and the alignment charges are correct, so the positive is close to the negative, they can actually form a very short, very slight bond between them called a van der Waals force, basically. So then fluorine's atoms are here, and chlorine's atoms are here. Now, van der Waals bonds are extremely weak bonds, and they happen instantaneously and break just as fast as they occur. These are weak bonds. Hydrophobic interactions are also fairly weak bonds. Ionic bonds are moderate strength, and sometimes for specific atoms they can also be strong, because once you give the electrons, sometimes it's very difficult to get the electrons back. And covalent bonds tend to be very strong bonds that are difficult to break. And that concludes this video.